Hello everyone, and welcome to the third video in this mini-series about coal power. So in this video we'll be taking a closer look into the science behind how the coal power plants generate electricity, and also looking into the combustion of coal and the science behind that too. So the general concept of how the energy production process works in the coal industry is to burn the coal in giant furnaces to release the chemical potential energy within the coal in order to generate thermal energy. So this thermal energy is then used to heat water and cause the water to boil into steam, which is then put under immense pressure in order to turn a massive turbine. The kinetic energy of this turbine will then drive a generator to produce electrical potential energy that is usable in our society. So now we'll take a quick look into the combustion of coal. So the combustion of coal is a very exothermic reaction that releases lots of thermal energy, which is great for use in power plants to heat the water to produce steam. The simple equation for the reaction is carbon and oxygen reacting together to then form carbon dioxide. However, in reality, coal is not simply pure carbon, although it does have a very large proportion of it, typically around 84.4%, assuming a dry, ash-free basis. Coal contains various other impurities, including oxygen, nitrogen, and most notably sulfur, which causes the release of sulfur dioxide that can cause acid rain, as mentioned in the previous video. So in reality, the combustion of coal reaction looks more like something showed on the screen, with carbon monoxide and often carbon as well, water and other impurities also formed, as well as just carbon dioxide. Now, the process of getting energy from coal must obey the second law of thermodynamics, which states that this reaction can only convert a fraction of the heat produced during the combustion of coal into mechanical work of the turbine. The rest of the heat, called waste heat, must be released into a cooler environment. The fraction of the heat released into a cooler medium must be equal or larger than the ratio of the absolute temperatures of the cooling system, which is the environment in this case, and the heat source, which is the combustion furnace. Raising the temperature of the furnace will dramatically improve the efficiency. However, it will also complicate the design, because more expensive materials will be required for the use, making it much more expensive. The typical thermal efficiency for coal and oil-fired plants is about 37%. So this is balancing the cost of the power plants and the efficiency of the combustion reaction.